Okay, great. Good morning, participants. A very cold and chilly morning to you all. It's really pleasure to be here with you once again for third part of our series. Uh, Earlier we conducted part. This is a four series part of Industry 4, and today we are going to discuss on series number 3, that is setting a strategy. The earlier series was first part of the series was why Industry 4 and how organizations need to start the journey. We covered the topics around what is Industry 4, do you have the foundation, why projects fail, and what are the leadership skills required to come do that. And the second part of series was what come first, and we did cover like how are the key findings of that part two series was don't do it alone. We have few challenges. We have to have limited expertise, quality of data, integration of team, and budget overruns. So that was the key findings for second part of our series. And let's begin with today's part of three of setting a strategy on part three series of our discussion. So I have my good friend with me here, John Broadbent, with around 40 years of experience in manufacturing industry, helping organizations to become smart and digital. His rich experience across different industries is really helped many of his customers across the world to jump on this strategy and create some winning organization. So John, the floor is yours.
Thank you, Faisal, once again. Thanks to Factory of Future for the opportunity to share this important information for those interested in moving along the journey of Industry 4.0. This is the third webinar of the four-part series, and I hope you've enjoyed the content so far. So today is actually about how to set a strategy. Once again, I'm John Broadbent from Realise Potential. This month is my 45th anniversary in manufacturing, so I've been there a while. I've got all the grey hair to prove it. Let's have a look at the agenda for today. So the first item on the agenda is, what is the secret sauce of Industry 4? What steps to take, the hierarchy of data, how to use it, and let's start off with what is the secret sauce. So the secret sauce, if you like, the backbone of Smart Factory and Industry 4 is really where everything comes together so that you can see in harmony what's really going on inside the factory. For example, you might have an existing collection of data sources. You might have databases, you might have HMIs, PLCs, SCADA systems, manufacturing execution systems, MES, and the other MES, which is many Excel spreadsheets running your factory. And really, trying to get information shared between all those systems is often the challenge. And we're going to go through why that can present some substantial challenges to the business. The secret sauce is therefore integration. It is getting all those disparate systems that natively don't talk to each other to actually share information, trying to achieve the utopian idea of one version of the truth, and making sure that you're not replicating or copying or transferring data or maintaining data inside multiple repositories. What does the term integration actually means? It means when separate things are brought together. In other words, it's about making sure that the information that's held in those different repositories can find its way into a place where proper contextualization and delivery to the people who need it best happens seamlessly, rather than someone working on a spreadsheet, making some changes, saving the spreadsheet, then passing that information on to someone else. The moment we start getting into the spreadsheet world or collecting data after the event and putting it into a PowerPoint slide and presenting at the end of month meeting means that we've lost the benefit of Industry 4 and smart factories, because that data is now old and out of date, and it's all looking in the rear view mirror stuff. Just to remind ourselves, if we look at the left-hand side of this slide, we have the two precursor steps before we can go on the Industry 4 journey. And these are the steps of computerization and connectivity. We have to be able to have our machines computerized with PLCs, etc. And we have to be able to connect to them to pull information, which is the predictability piece. And then we can optimize our processes in advance, which is the adaptability piece. So the system starts to learn to adapt to impending changes in the process so that we don't have to worry about that so much as we do in manual methods. This next slide is the Industry 4 development path that was developed out of research by a group called Acatech. And it is the first part of the process is what are we seeing? Why are we seeing it? What will happen and how will that affect us? So this is really what are we seeing, which is the connectivity piece. Why are we seeing what we're seeing, which is the understanding piece. What will happen as a result of what I'm seeing so we can prepare for an outcome, and how will this affect the production, for example. This is the self-optimization piece. And the value of the Industry 4 development path increases as we move further from left to right. And what this also means is that the first part is making the data available. The second level of maturity is making it accessible. The third level of maturity is making it active. And the fourth level of maturity is making it action-oriented. That means that we can do something with the information that we've collected. Why is this a benefit? Well, integration provides visibility into what's going on within a system and around it. If you can't measure what you're doing, you can't improve. If you can't see what's going on in your processes, you can't do anything about it. And often, a lot of quality issues that we find after the event through product recalls and things like that are because we haven't been able to see in real time what's going on within a system or around it in the supply chain. The other point is that integration gives us the ability to capture and store that information for historical retrieval. I know many businesses, particularly in the food industry, that collect tens of thousands, hundreds of thousands of sheets of paper every year. And in fact, a friend of mine a couple of years ago, a work colleague, did an audit on a food business, and they collected and stored 900,000 sheets of paper every year. And that was in one factory. So the dream of getting into a paperless factory where information is collected in real time, stored for instant retrieval and for pattern matching and for machine learning and for artificial intelligence, we can only do that if we can connect, extract, transform and store that information in historical repositories for future retrieval. The third level is the ability to then mash up that disparate data to build relationships. Sometimes we don't know that an event in one system can actually cause an outcome in another. And those causal relationships can remain hidden if we can't compare information from one system to an event in the other system. If we can't see that an input from one system called an output in another system. And point three can be both live data. So the mashup can be both live data and understand that mashups actually give the ability to do both. The fourth reason is it gives us the ability to see cause and effect conditions. It improves our ability to do our 5 whys and root cause analysis. Many times I've come across organizations that know they have a problem. For example, the company I was dealing with last year had a problem making food. The food went through an oven. The trays came out of the oven and then went into a sealing machine. But every now and again, they would have trouble sealing because the trays of food would be distorted. But they didn't know, was that a problem in the oven because the oven was cooking, the zones in the oven were too hot and so they were distorting the trays because they weren't collecting that information? Or did it happen because the trays themselves were faulty? So not having that information meant they couldn't actually determine the cause. And so they had to put a lot of people into the problem to try and solve it. And to my knowledge, that problem is still not resolved. The fifth reason for integration is that it creates a foundation for future machine learning and artificial intelligence applications. If you remember, and I think we come across it a little bit later in this presentation, in webinar 2, we talked about the data pyramid, and we needed to make sure that we had all the foundational parts of the data pyramid: the connection, the extraction, the storage, the contextualization, and the BI data cubes and data lakes and all that stuff in place, so that we could then get to the icing on the cake, which is the artificial intelligence and machine learning applications that are now starting to emerge in places like Google, Amazon Web Services, Microsoft, and places like that. If we don't have the data stored somewhere in the first place, and meaningful data, there is no way we can then train machine learning and artificial intelligence engines to do something with it. And there's a bit more on that coming further in this presentation. I also want to introduce you from an integration point of view. You're probably familiar with this slide where you have a plethora, a good old English word, of multiple data sources in your business. You might have SCADAs and HMIs, you might have distributed control systems, MES, custom databases, spreadsheets, plant historians, SPC, laboratory information management systems, maintenance systems, a whole heap of stuff. And really it's about making sure that you can connect that stuff using what's known as manufacturing integration. That's the integration layer. And we talk about the ability to do what we call vertical integration. And some organizations have actually mastered this pretty well, in that they can take information from their ERP, push it down through a manufacturing integration platform and distribute it out to other systems. They can also collect information back up to the ERP. It's known in the industry as top floor to shop floor. And this is quite common, and I've done many projects over the last 20 years where vertical integration has been the main methodology. What's often missed, though, is what I call the horizontal integration. And this is the ability to develop an integration platform whereby information is shared between systems that natively don't actually talk to each other. And this is so open with potential that many organizations completely miss this opportunity to share information between systems as production flows along an internal supply chain. From the time that you receive the raw materials, issuing of raw materials, production, work in progress, finished goods, byproducts, right through to the final product, onto pallets, for example, and then out the door. And a product during its life cycle within goes through many of these silos. And so that the sharing of information through those silos is a very big part of most organizations that miss that opportunity. So the horizontal integration piece is a very important piece. And the reason for that is, if we have a look at this, what's called many-to-many model, I want to take you through an example. Let's assume we have a data source represented here by these two little database, this icon, and then we bring in another system and we need to develop an interface between the first system and the second system. Then we put the second system in, we understand the way that these two systems need to talk to each other, and we develop an interface. We develop both a send and receive, if you like, at both ends of the communications channel. And then come along as our business starts to grow, and we then develop or buy a third system. So now we have another data system, a data source in our business. It could be a laboratory information management system, for example. And we now need to develop an interface between our first system and our third system. But now we also need to develop a system between our second and third systems. So now, as you can see, as we start to include new data sources in our manufacturing environment, we start to increase the complexity of the number of interfaces that we develop. And then, of course, along comes system number 4, which is a new system altogether. And now we have to develop another 3 interfaces to the other systems in the facility, and we have to do so without disturbing those systems or disturbing the pre-existing interfaces. What happens when you then have to do this in the real world? And I was involved in the Ravensthorpe nickel operation in 2005, 6 and 7, where we had 63 interfaces. For those of you familiar with the distributed control system, the DCS alone in this facility had 2.5 million tags. And they had so many systems inside this facility. It was one of Australia's largest infrastructure projects at 4.5 billion, I think was the cost. And I was very fortunate to work with a solution architect who really knew his stuff. And this was the first time I'd come up against a problem as complex as this, because you can imagine if you had 63 disparate systems all having to talk to each other, what that might look like. And he made the comment to me, he said, can you imagine if we have to replace one of those systems? We would have to decommission all 63 interfaces to that one system. Then we'd have to develop 63 interfaces from that one system to all the new systems. And then we'd have to test them, regression test them, and commission them. Obviously, a completely impossible problem to solve, and a real, what I would call a rat's nest issue. So the question is there a better way? Well, the good news is there is. And I have to owe this to my the project manager that I work for on that project, because this particular methodology I've used multiple times since. It has absolutely stood the test of time and shown to be amazingly reliable, and it's elegantly simple. And it's called the hub and spoke. The hub and spoke is where all those 63 systems, if you like, are satellites. They're the spokes out to the individual systems that sit round the rim of a wheel. And in the center, you have the hub, which is the integration platform itself. And if you think about this, it means that you can replace any one system. And all you have to do is make sure that the information you get from that one system, when you put a new system in or upgrade a system or change a vendor from, for example, SAP to Oracle, all you have to do is make sure that the information on that pipeline between the hub and the spoke remains the same. If it changes, you can change it at the point of entry into the hub, and then everything's connected to the hub, nothing needs to change. I was very fortunate in 2011 to be able to do this for Coca-Cola. This is an example of their smart factory. You might be able to see a person up at one of those windows, but apart from that, there is nobody on the factory floor. This was built in 2011. Its 9-year anniversary was last month. And it is still what I consider one of the smartest factories that I've ever had the pleasure to work in. And I was responsible for the integration of this facility. It's still a dark factory, a lights out factory, effectively 9 years later, and still running world-class standards. And in fact, in 2019, won a Global Packaging Award for its innovation. As you can see, it has automated guided vehicles here, which do all the product movements, and everything in this business that opens and shuts, every event, every process is monitored tightly within the hub. And what it looks like is something like this. We have a digital hub in the middle of the facility, and it communicates with all these disparate systems. So in the top left-hand corner here, we have the raw materials area of the facility. So the raw material silos every day, the system, the integration platform in the middle sends an email to the resin supplier and tells the resin supplier the volumes and the weights in the silos, and emails them with the actual weights every day, so they know whether they have to make a delivery or plan a delivery within the next 48 hours. It takes information from the dryers to make sure that the plastic that's being supplied to the process is of suitable quality. It connects to the dedicated manufacturing execution system that came with the injection molding machine and sends the orders from SAP through to the MES. It monitors the inline quality vision inspection system and takes those quality results and passes those back up to SAP Quality Management. It tells the automated guided vehicle system that bins need to be picked up and what the source and destination is. So the AGVs know what to do, where to pick up and what to do with the bins. It actually produces the palletizing label, which I'll come to in a second, because there's some secret sauce in that as well. It monitors all the conveying systems. It monitors the bin assembly station, so it knows of any issues in the supply chain at the beginning of the process where these bins are assembled automatically in a machine and then delivered into the process. It monitors all the services, power, water, gas, air compressors, etc., through multiple channels. It takes information from the lab-based laboratory information management system and pushes that again through the integration platform up into SAP. It has a quarantine hold system where if any bin is suspect or we are seeing repeated alarms coming out of the vision inspection system that's telling us there are repeated quality issues which are graded into critical and non-critical. The integration platform, if it sees critical alarms coming out of the quality inspection process, it can actually nominate the bin to be a quarantine bin, therefore wanting some human inspection interaction and some quality control. Any bin that then disappears or gets lost for whatever reason through a system failure can end up in what's called a hospital station, which is again a human place where the bin is dropped off by the automated guided vehicle. There is obviously a barcode on the bin. Every bin is serialized, and the hospital station operator he sees the bin at the hospital station. He can go down to the hospital station, scan the barcode on the bin, and up comes a screen that tells him everything about the product that's in it. It also produces all the shift reports. When this factory first opened, they were producing Excel spreadsheets about their shift reports. And when we took a look at the shift report about 6 months after they opened, we realized that 80% of the data they were putting into their Excel spreadsheets was already in the process. So we were able to automate the shift report collection and give them only information what they needed to enter. Obviously, as I said before, it communicates SAP bidirectionally in real time. It also generates alarms and produces a site-wide dashboard which shows the full factory layout and where areas of the factory might be in fault. And that requires the technicians that run the place to then go down and have a look at the system itself. Even though we could tell them what the alarm was, we decided that the only way this would work well is to actually have the system fault alarm, a general alarm, appear on the dashboard. So they have to get off their bottom and walk to the actual source system and interrogate the system to see what was really going on, because there's virtually no people on the factory floor. If you think about this, any one of these systems, they could replace the AGV vendor, for example, with a completely different vendor, and all we would have to do is maintain that one interface between the AGVs and the integration platform. So I'm hoping from this, for example, you can see how this hub and spoke model really does produce some amazing benefits. I mentioned earlier that the label that appears on the bins once they're finally completed looks something like this. This is a description with some information, obviously, on what's being produced, some batch information, and down the bottom here, an SSCC label that contains some information about the contents. Now, to someone who might understand how these labels are made, you could print this in an Excel spreadsheet. You might be able to print it from something like SAP, but a lot of this data actually doesn't reside in SAP. So I want to demonstrate how by having an integration platform, you can do some quite extraordinary things. If you have a closer look at this label, you'll actually see there are 6 different data sources. There is data coming from SAP. There is data coming from the integration platform, in this case called MII, Manufacturing Integration and Intelligence, which happens to be an SAP product. There's the license plate information over here where it says the bin license number 12345 is coming from the AGVs. There is quality data in terms of the quantity that was inspected coming from the inline vision inspection system. There's resin batch and silo information where the raw material was chosen to make this from the injection molding manufacturing execution system. And the SSCC number itself down the bottom here, which travels with the bin, actually came from a labeling engine. So I'm hoping you can see that you couldn't actually produce a label as complex as this or as informative as this to a human if you did not have these systems fully integrated. So the question I'm often asked is, well, what is the integration cost? How do you put a budget together to not only connect, but integrate all this into a platform? And my experience has shown me that the integration cost is remarkably rather small. In all the projects that I've done in the last 20 years, the integration cost is typically only 1 to 2% of the overall capital cost. I'll give you an example. That job that I just talked about at Coca-Cola was a 60 million Australian dollars, so say 40 million US dollar factory, greenfield factory, and the integration cost was about 600,000 US dollars. So that's about 0.75%. And I've done many of these projects. You would typically look for 2% of budget for a smaller facility, because the bigger the job, the lower the percentage. So on another $60 million project I worked on 5 years ago, the integration cost was again about 600 or 700K. So again, maybe 1 to 1.2% of the overall budget. So be aware that the integration piece is a very key component. It's like the last mile of building a smart factory, and yet it's that 1 to 2% that most organizations fail to include in their budget. And so you then end up with all these islands of information being scattered around your manufacturing facility, whereas if you'd spent 1 to 2% extra at the point of commissioning of that equipment and the installation of that equipment, then you would be able to get the information out of it to then do all this really great stuff. So how do you actually get this going? What steps do you need to take? So to go back to episode 1, I think it was, Faisal, we talked about what can you get? What information do you already have in your process? And I introduced you to a thing called the 3 buckets model. And if you remember, we had 3 buckets. The first bucket was the easy have bucket. What do I already have in my manufacturing facility where I can get existing information from? Is it a PLC? Does it have an Ethernet module? Is it connected? Is it on my network? And can I use, various tools, which we'll talk about shortly, to get that information? The blue bucket was, can I get it with a little bit of effort? And sometimes that may be that you have a PLC in the factory, but it doesn't have an Ethernet module. So you can buy an Ethernet module for a few $100s, run some cabling and start getting the data out of it. Or do I have some other kit in my factory that is so out of date that I now need to invest in some CapEx or some OpEx, the red bucket model, and I need to invest more money, and that's the harder to get stuff. I will guarantee you that if you've got a reasonably modern factory, 80% of the data that you need is already in the easy have. 10 to 15% will be in the can get bucket, and 5% or so will be in the red bucket, the CapEx, OpEx piece. So the next question is, okay, I've got my equipment, I have some networks, I've got some connectivity, I've now got all my PLCs and SCADA systems out there, or my building management system out there. How actually do I get the data out of it, and what can I do with it? Sometime 20 odd years ago, the OPC Foundation, I think it might have even been in the 90s, was founded. And OPC stands for Object Linking and Embedding for Process Control. And the OPC Foundation started to get developed with standards on how best to share information and communicate between source systems and things like PLCs in particular. And OPC went through a whole series of evolutions. There was originally OPC DA, which was direct access, that was getting a real-time information from a data point like a tag, a temperature, a pressure, a flow, directly out of a process. And then they added OPC HDA, historical data access, which is going back and collecting data out of a system that might have collected some history, like a process historian. And then they added OPC A and E, alarms and events. And this was an opportunity to collect information of events and alarms, which is often high volume, and do something with that as well. But OPC 1.0, then OPC 2.0 came out, and there's all sorts of issues with distributed management. And eventually over time, the OPC Foundation finally decided to really do some heavy investment, and they developed the OPC UA standard, which stands for Unified Architecture. And it means that the ability to get direct access, a tag data point, historical data access, and alarms and events are now all embedded in the OPC UA standard. So you can now go to the market and you can buy or rent software as a service, and you can buy yourself an OPC server. An organisation called Kepware, which is owned now by PTC, has been around for 20 something years, and that's the one that I've used the most. And I absolutely love it because it just works. And for, I think, around about 1,500, maybe $1,000 a year, you can now get their manufacturing suite, which supports 150 different brands and models of PLC. Mitsubishi, Omron, Siemens, Allen Bradley, Beckhoff, you name it, they've got usually drivers to talk to it and collect information from it. Another one is called Matricon OPC, which I've had some exposure to. There's one out of Europe called Codasys. And what I'm seeing now, rather interestingly, is some PLC manufacturers are actually putting their OPC UA servers on the PLC CPU itself. So if you have an OPC client, you can connect directly to the PLC and browse its namespace and see what information you can connect to, extract, and store. It's quite remarkable. So all you really need to do to light up your factory, once you've got connectivity and cabling and firewalls and switches and all the stuff that you need in place, is something like an OPC server, or talk to your PLC vendor and find out they do an embedded OPC UA server on the PLC itself. The other methodology that's becoming quite common is called the MQTT, which stands for Message Queuing Telemetry Transport. It's an open ISO standard, lightweight protocol, which uses like publish subscribe network to pick messages up and push them somewhere else. So mqtt.org is an open platform. As an example how this might work, you can have, for example, a product such as ThingWorx. This is a ThingWorx dashboard. It's also owned by PTC, and it's not initially cheap. I'm not sure of the cost in India, but I know in Australia it's about 20 to 25,000 US dollars to get started with the platform. But the good news is it's high cost up front and then very cheap to implement and maintain at the back end. So a very low total cost of ownership compared to other systems. And here's an example of a mashup from multiple data sources. And they also have these little widgets like OEE that you feed the data into it. It just knows what to do with that data and produces these little graphs for you. ThingWorx can sit in the middle, hub and spoke, funnily enough, and be the hub in an integration platform, and it can talk to a whole range of systems. These are the data sources up here: JSON, XML, can talk to things like SAP, Salesforce, Oracle, can talk to historians like OSI, Pi, and Wonderware, can talk to devices, can talk to HMIs, can do devices in the cloud, and etc. So you can see there's lots of areas where ThingWorx can sit in the middle and be that exact hub and spoke. So what happens is, here is an example of another platform called Ubidots. Ubidots is a very interesting tool whereby you could have an IIoT edge device, so a smart transmitter. You point it and configure it to send its data to an MQTT broker, and the MQTT broker then pushes the data up to Ubidots. And the way that the Ubidots model works is a dot is an endpoint. So let's assume you've got a tank level or a temperature in a pressure vessel. That's considered to be a dot, and you can take the data from that device, if it's MQTT enabled, push it up to an MQTT broker, push it up into Ubidots, and use these widgets and build yourself very quickly and very easily a dashboard. A good friend of mine who operates in this space recently took an edge device that someone had given him, and he connected that edge device, got the value from it, pushed it into an MQTT broker, pushed it up into Ubidots, and produced a tank level gauge and a trend, and that took 1 day, end to end. So the tools are now developing out there to do this stuff really quickly, really cheaply, compared to how it used to be in the past.
Yeah, John,
This is another company that I'm familiar with here in Australia. Yeah, Faisal?
One question,
You have a
John.
question?
Yeah, if we have the hub spoke formation, what happens when the hub fails? Since we are relying on one system which is integrating all the integral important parts, so what happens if there are some issues or problems with that?
So the MII hub that I talked about at Coca-Cola
Hmm.
sits in fully hot redundant.
Okay.
So the systems these days that do that role of integration are usually hot swappable. So in the Coca-Cola case, we had to do a test where we absolutely turned off the machine, like basically powered it down in the middle of its process, and its mirror copy picked it up and just continued to run as if nothing had happened. So you need to have obviously good disaster recovery planning.
Yeah, that is also good. Okay,
And
great.
you can have hot swappable systems,
Hmm.
AWS on premise, whatever you use, and the systems these days natively support that hot swappable capability.
Okay, great.
This is an example of a company in Melbourne called Blue IoT. They collect device information from devices in building management, like mechanical services, air compressors, chillers, all that sort of stuff. They put the data up into a LoRaWAN, a long-range wide area network controller. It gets broadcast up to a LoRaWAN hub, and then it goes up to the cloud, and they then do the analysis for you as part of the service. And these guys don't even charge you for the edge devices. They rent them to you. So they amortize the edge devices as part of their monthly subscription. So this is an operational expense rather than a capital expense. And as an example, this is the results that they did for a multi-story building in Melbourne, where from March to June 2018, this was the consumption of electricity of 35,331 kilowatt hours in that quarter, and they reduced that to 27,000. And then for the HVAC, they got that from 16,000 down to 8,500. So the payback period on this, I think, was about 4 to 5 weeks. So, there are systems out there now that can allow you to do that. So for you, it's obviously fit for purpose. You have to find out what works for you. Hierarchy of data. If you remember, we previously talked about that hierarchy of data. Down the bottom, we actually have this initial data layer, data acquisition, the IoT, it could be social media, it could be an ERP, it doesn't matter what the data store is. And then we have to move it into a layer where we do the data engineering, the ETL, and extract, transform, and load, enterprise data warehouses, etc., enterprise services bus, which prepares the information for delivery. We then have the master data management and quality cleansing piece, which sits in the middle. Then we put that into some report repository for the BI and business intelligence to sit over the top, or advanced analytics. And only then can we do the data science piece. Only when all those 4 layers are in place and working effectively and efficiently can we then do the artificial intelligence, the deep learning, the machine learning, modeling, and all that sort of stuff. And it's this bit in the middle, as I mentioned before, which is the biggest challenge, where the stewardship of this data in the manufacturing world is often missing. So take a look at your own organization and see whether that stewardship is in place. It's usually there for master data, for ERP, but it's rarely there for the automation IoT space. So then the question comes, well, how do you use all this information? Well, really, there's no one answer to that, and that's what we call horses for courses. You have to know what course you're running, and you have to know what horse to use. But what we do know is this, that if we look at the traditional way of how we constructed our data models, if we imagine our typical how you might be today as a business, where you have your 2-dimensional, SQL tables, Excel spreadsheet, whatever it is, and we have a graph or a trend that might come out of one of those systems, we're really getting old answers to old questions. What was the OEE on line 6 last week? But as we move along more on that vertical axis and start to get more complex data models, we start to be able to see relationships that we didn't see before. So we start to get new answers to old questions. If we then move horizontally and start to increase the complexity of our ability to do analytics, we then get old answers to new questions. Finally, when we combine both the advanced analytics and advanced data models, we get to the holy grail, which is new answers to new questions. And this is where innovation takes place. I am not yet seeing many organisations in Australia, and it's probably the same in India, where we're getting new answers to new questions because, frankly, we don't know what questions to ask yet because we're still maturing along those two axes.
Yeah.
I am going to share with you an example, though, where a young man who's a digital native at about 28 or 30 years of age started to ask some questions, and he's a Mars Wrigley production engineer, and he decided to ask the business for 30,000 Australian, so 20,000 US dollars, to take some data because he believed that with a proper analysis, a machine learning or artificial intelligence engine could find some cause and effect relationships to help him optimize his production schedule. So he took the data that he had in a traditional two-dimensional database, a spreadsheet, he pushed that into the Google Cloud, and he got it to do the analysis and machine learning. That $30,000 Australian investment yielded $2 million uplift over 12 months in optimizing his production schedule. Now, he made that investment not knowing what he was going to find. He didn't know what he didn't know, but he had faith that providing gigabytes of data into the Google Cloud to do this analysis for him would find stuff that no human could possibly find. And I can back that up because recently one of my clients, we've done a pilot program with AWS, Amazon Web Services, using the Amazon forecast tool. And we provided them 2 years worth of sales data by week for, I think, eight products over that 2 year period. And we got it to model that data and predict to January this year what our sales forecast would actually look like based on 2 years worth of previous history. So we gave it 2018 and 2019. And then we compared the AWS forecast with our actual result. We found that the AWS forecast gave us a 17% uplift in some products, a few percent uplift in another few products, but overall, we gained 7% in our ability to accurately forecast what was being made. So the machine learning tool was 7% more accurate than the human was. And the good news about machine learning is the more we feed it, the more information we give it, the better it's going to get. So don't underestimate these tools. However, to feed them and give them the information you need to have that information collected and stored in some form in the first place. So one of the questions I'm often asked is, yeah, but what steps do we take and what does the future look like? Well, as Peter Drucker said, if you want to predict the future, why not create it? Have a look at your own business, see where you are, set your vision for the future and design your strategy to get you there. I've just done some work with a business where we've set their 5-year strategic plan in regards to Industry 4 and IIoT and Smart Factory. And they now know what their business would, they now know what they would like their business to look like in 2025. And I've introduced them to a thing that I call the 3 horizons model. This is well known. I think it was done by McKinsey's. And the 3 horizons model is this. If you look at a timeline and value from now for Horizon 1, which is 1 to 2 years, Horizon 2, which is 3 to 5 years, and Horizon 3, which is 5 years plus, the research is showing that on Horizon 1, which is the here and now, you should be spending sort of 75 to 80% of your time and focus. For Horizon 2, which is 3 to 5 years, should be 10 to 15% of your focus. And for Horizon 3, which is 5 years plus, you should be spending 5 to 10% of your focus. This means that you, in year 1, is all about defending and expanding your core business. In Horizon 2, it's about foster emerging new business. And Horizon 3 is all about seeding future business. And this really results in about 2 to 3 hours per week of blue skying, brainstorming, thinking about, well, what does my business look like in 5 years' time? What products are we making? What markets are we in? What does our customer demographic look like? What equipment do we need to make those products? How much of it is stuff we haven't even thought of yet? It's about seeding future business. And I would ask you a question to think about is, how much Horizon 3 thinking do you think SpaceX and Tesla do? And they'll be spending more than 2 to 3 hours a week per person in their business, let me tell you.
That's
However, you
really
have to be very mindful in your business of what I call the grey head ceiling, of which I am one. And this is people in your organisation who've been there for a long time, think they know everything, and will tell you that the idea you have will never work. And the reason is that the grey-haired ceiling is somewhat afraid of what I call the digital natives. They're the ones that use 2 thumbs, and the digital immigrants, which is me, we use 1. So my advice to the grey-haired ceiling is to get out of the way and let these young people who want to have a play with these tools, they have the smarts and understanding as digital natives and how to use these tools, give them some money, supervise their work, but let them loose. So in conclusion, integration is the secret sauce. When separate things are brought together, you have to consider how to construct an integration platform with that hub and spoke idea. You then have to have a roadmap in place. Design your roadmap. Where do we want to be along each step of the journey? It doesn't mean you can't take detours. It doesn't mean that you can't adjust the end destination, but you must have a strategy to get you there. Be mindful of the data pyramid and make sure you have the governance piece in place. Design your future, establish how you want the business to look in 5 years plus, and design the steps and strategy you need to get there. So thank you for today. Please feel free to reach out to me on LinkedIn. And if you do, I will send you a copy of the Industry 4, How to Improve Manufacturing Performance Using Industry 4. If you haven't already got it, it's a free white paper that's doing the rounds that I've had great feedback on. And based on that, it's over to you, Faisal, and thank you for attending and some Q&A.
Yeah, John, it's really interesting. So what I see is that being part of this 2 and 3 series, I believe, John, that there's a lot of work on the first and second step, to
Yes,
be able to reach to this third step. It sounds so simple by integrating all this complex leveraging, but
yes.
there's a lot of substantial work to be done at level 1 and level 2. So participants, if you have any questions, please chip in on the chat box. And by the way, John, we have also premiered the first and part 1, part 2 series on YouTube. I will just share you
Okay,
the link so that
great.
we can have other participants who have missed the series before can catch up with what we are about to say. So I think there is a lot of possibilities to integrate. I mean, I didn't believe there is a dark factory still exists, and it's really wonderful, John, that you have worked with. What are some of your key experiences for that project?
Oh, well, the Coca-Cola facility in particular was the first time that I was really given the opportunity. Yes, the BHP Ravensthorpe, but it was such a big project that we were a very small part. But the Coca-Cola factory, we were given the opportunity to do vendor management, talk to the vendors, find out what they had, what systems they were using, what PLCs, and come up with that hub and spoke architecture. So documents were written by me prior to the equipment even arriving on site from overseas as to how we're going to communicate, what we're going to communicate, what information we could send them, what information we could get back. So the data model was effectively built before we even started commissioning. When they arrived on site, we then could do the testing one-on-one, and we'd already commissioned or tested the integration piece itself, the bit at the back, the hub. We'd already worked with the hub, so we knew how it operated. We'd already designed the database to store that information as a persistence layer, so that every piece of information we got from any system was persistent, and then another process would pick that new information up and distribute with a publish subscribe model. So the learnings from that was that if you build along that design, you can actually end up with a really awesome hub and spoke arrangement. And the advantage of that is that the reliability of that system has, in my view, been legendary. I think in the 9 years, we've had possibly one outage, and I think that was because they upgraded the underlying VM operating system, and it crashed the whole damn stack of which we were sitting on top. But as an operation, I think in 9 years, that particular platform's not had an outage. from the point of view of system failure, which has been remarkable.
Yeah. One of the participants is asking a quick recap of part one and part two.
Say again?
One of the participant is requesting for quick recap on part one and part two. I mean, what you can watch
How
our
to
YouTube
condense,
video links.
yeah, well, how to condense two 45-minute presentations.
Yeah.
I can't remember what part one was about or part two was about. I think part one was all about the precursor steps, connectivity, computerization, getting the foundations in place. Do you have a digital strategy? Do you have the leadership? Do you know where you're going? It's impossible, hear me out here, it's impossible for a person at a factory floor level to take the ideas and push those up through a non-cooperative leadership.
Hmm.
You absolutely have to have the leadership involved, and they have to be committed, and it has to be top down. If you try pushing from the bottom up, you will automatically meet resistance and nothing will get done.
Right.
Projects won't succeed. And I think it was also episodes 1 and 2 were about alignment between people, systems and processes. The system will fail every time if there's no alignment between the people and the process. So you have to get your processes in order, because if you don't and you digitize a broken process, you get a broken digital process.
Right. So participants, you can go to our channel Factories of Future, and where you will find our part one and part two series on YouTube uploaded, so you can catch up with all the past findings, and then you can link the part three also, which will be uploaded soon. So this was a very interesting series. It's a key element to complete the picture of Industry 4, and John very well explained it in a very simple and lucid way. So participants, if you want to develop your industry 4 strategy path or maturity path, we, John and myself, can help you to develop this kind of strategy and how to move forward. And as John said, that it's very important that leadership and the top management scope for taking this up is very important and the key element, as we always say, for any of things. Yeah, John.
And part 4 is really how you then kick a project off, and how to identify it, what's the low-hanging fruit, how do you kick a project off, and how do you then maintain momentum? What do you have to have in place to make sure that any projects you do go along the strategic path that you've decided? Who's on the bus? What colours the bus, and where's the bus going?
And who's the conductor?
And who's the conductor? That's the big
Yes.
one. Who's the chairperson?
Great. So great participants here.
Pradeep,
So Pradeep is here.
do
Okay.
you have a question, Pradeep? Oh, Pradeep's off mute.
So okay.
Hello, Pradeep. No, he doesn't want to talk to us.
So maybe okay. So we look forward for you to join our fourth and the last part of our series on Jan, and the invitation will come to your email box. And soon, okay. So we want to have a small pic also. If participant can keep their video mode on, so that we can take a small snapshot. My good friend Shailendra is also here. After a long time, Shailendra, how are you doing?
Hello. Hi, sir. Doing well.
Great,
What about you?
Shailendra.
Yeah.
Okay, so let's say cheese. Okay, I got it. Great. So participant, look forward for you to join a part four series of the last series for Industry 4, and we will soon send you the invitation list, and look forward to see you there at the event. It was
Happy
really
New Year,
pleasure
and
to.
see you in January.
Yes, Happy New Year to you, and have a wonderful season holidays, John, with you and your family,
Thank
and all
you.
my participants here. Have a great time with your family, and we see you at the other side of the year. Great. Thank you very much for joining.
Bye-bye.
Take care.